Alright guys, welcome back. Now we're looking at activity 4, and here we had to read a passage that spoke about a couple of materials and their respective melting and boiling points. So one of the questions that we have there on 1a is to name all substances described in the passage. So if you take a look at the substances that were described in the passage, we have lead, we have silver, gold, we have salt, we have copper, and we have ethanol. Okay, so I think we've came across all these materials in one way or another. Potentially, we have not really been told that this is silver or this is ethanol or this is lead, but we've actually come across them in one way or another. And Part B then asks for each of the substances that has been used to describe in the passage. And explain how its MP and BP make it suitable for the use. So I took the liberty of writing this in advance so that the videos are not too long. Okay, I usually try to keep them short. So lead melts at very low temperatures, and so what we use it for making electrical fuses. The electrical fuses are the ones that you find in your plugs. Okay, they're meant to protect your appliances, and how they work is that if you have too much electricity moving through the fuse, okay, the fuse will melt. That's at that point we normally hear like an explosive sound, and the circuit is broken where we have the lead fuse. Okay, so this protects your appliance in the process. So that's why lead will be suitable, because of the temperature at which it actually breaks. And depending on the appliances that you're using, they have different fuse ratings. Some can have 18 amps, some can have even more, some can have even less, depending. And then the other ones that we're looking at are silver and gold, okay, which have, and notice the description. I would actually encourage you to try and maintain those descriptions there. Moderately low melting points. Okay, so they're not really low when you think about them, because they're relatively high. They're like in the regions of 900 to about 1,000 degrees Celsius. For us, they're relatively high, but considering and comparing to the rest of the other substances, they're relatively low melting points. So which means that we use them with equipment that normally does not reach high temperatures, otherwise they will melt, right? That's one of the uses are usually with equipment, or in equipment, or as part of equipment, where we don't reach high temperatures. All right. So the last one that we saw there is salt, which has got which we're going to say has got again a moderately low MP, a moderately low melting point, and it can be used. It can be used. We said. To store heat or to transfer the heat as well, because once you melt it, it's a very good substance that retains the heat, so we're able to transfer heat between places, and when it gets there, it still retains that heat enough to be able to use to generate electricity during the night. And I think that property becomes very important in places where you may not have, let's say, a lot of energy sources, or energy is very expensive, and you just want to use your energy efficiently for the longest period possible. So you just merely melt your salt. Once your salt is molten, you're able to keep the heat within the salt, or take that or just have that molten salt flow from one place to another, and wherever it flows to, it can be stored there, and it can then be used to boil water, forming water vapor. The water vapor then causes pressure, which turns the turbines, and therefore we generate electricity, or any other activity for that matter that we can use the stored heat for. And moving on to question 2. Question 2 is saying that explain how the melting and boiling points for the following substances make them useful to us. Now understand, the question is saying to us. It's not just useful in general, it's actually useful to us. And I took the liberty again of just writing those in advance, okay? And water is a liquid at room temperature, all right? And how is this useful to us is that we remember we need water for nourishment, and it's part of the 7 important nutrients that we need to use for nourishing our bodies. And for that matter, we need to have it in a convenient form to be able to take it in. And the liquid form is very convenient. We just need to drink it. Imagine if water was a gas. You would need some special device to be able to take it in. Or if water was always a solid, it would not be very convenient or conducive for you to be able to swallow. You have to chew it, you have to break it down first, and so on. That's why when it's a liquid, you just take it in without a problem. And again, water can be a solid at particular temperatures, especially very low temperatures, which means it's very easy for using it to cool down substances that we need to cool down. Like, for example, when you guys go off to a beach and you want to keep something cool, you can carry the solid water, which is your ice, and you use that to keep your fizzy drinks cold. And now we're looking at candle wax, candle wax, candle wax, candle wax. Now this one has a relatively low melting point, okay? Because normally your candle wax, the whatever the color may be, it normally melts at the temperature that enough that a flame can be able to melt it. In other words, all you need is just a normal flame and candle will melt. And so when it melts, the good thing about it is that it's a type of a fuel, okay? And because of this, remember with fuels, we can use them to produce energy. And that's why it becomes suitable, because when you have the fuel burning, light is going to be produced, and sometimes even heat can be produced. So when we have candle wax, in our particular case, the emphasis is to produce light. So when you have like a candle wick, it derives its fuel from the molten candle material, which then burns and then produces the light that we need. So because it's easy to melt it, it means that it's very convenient again for us to be able to produce light without having to put a lot of heat in. And again, it easily becomes a solid, which means if I want to put out the flame and store my candle, all I need to do is just to extinguish, which is to put out the flame. And voila, what do I have? I have my candle back again as a solid. And it can also be used for sealing envelopes, which is what we used to do back in the day. You know, it would really be very majestic. You would just have a few drops of your candle wax onto the back of your envelope, and it seals when it hardens and cools off. And then the last but not least, we have steel, which we say has a relatively high melting point. So because most of our food is cooked at a particular temperature and not beyond that, otherwise you'd be burning it, we would normally use steel implements to be able to make cooking utensils and so on, because they can withstand the temperatures that we cook at. And again, there's a lot of other reasons besides just the MP. Of course, there's issues to do with hygiene. There's issues to do with ability to be molded into particular shapes and so on. But in this particular case, we're dealing with the melting and the boiling points. And so steel becomes relatively useful because of that. And the question 3 was asking us, this is a very interesting question. I'm sure some of you may have came up with different answers as well, because we have many other substances that may be deemed to have high boiling points. But the one that I found was tungsten, which is also known as wolfram. Hence, if you look at the chemical name in the periodic table, you'll notice that it's actually a fancy W, and you'll be asking yourself, where's the W coming from in the word tungsten? It's because it's also known as wolfram. Unfortunately, some of the chemical names that we now know things by today, there were already some names that existed before, so those names still carry weight, hence the W there. And this one melts at an incredible 5,660 degrees Celsius, which is pretty very high. If you remember, we were talking about the gold melting at about 1,064 degrees Celsius. Now this one is like way over 5 times that, which is very decently high. And yeah, I think that does it for activity 4. And I'm just going to move on to activity 5.